We have a beam. This beam called AB. We have 4 concentrated load, 2 kib, 2 kib, 2 kib, and 2 kib. A is a roller support. B is a hinge support. We are looking to calculate reactions. Calculate reactions for the shown beam. So, first step, do you remember? What will be the first step? What reaction do you have? The problem is helping you. A is a roller. So we have only one reaction at A. This reaction perpendicular to this base. I'm gonna call it or label it Y because it's in Y direction, A because it's at support A. For support B, it's hinge or pin support. So we expect 2 reactions, one vertical and one horizontal. The vertical one will be YB, the horizontal one will be XB. Guys, to remind you, you can assume any direction as you like. For support B, for example, you can assume your reaction like this and like this. Or you can assume your reaction like this and like this. It's up to you. But we need one horizontal and one vertical. The vertical one called YB, the horizontal one called XB. YB and XB. So you can assume any direction, left or right, up or down. But keep in your mind, for pin, support, or hinge, we have 2 reactions. One vertical and one horizontal. Any questions so far? Any questions so far? Okay, second step. How many equilibrium equations do you have? Do you remember? We have 3. Rigid body in equilibrium. The first equilibrium equation summation f of x equals 0. All forces in this problem in x direction, add them together, the summation equals 0. So please don't forget any. What forces in x direction in this problem? Actually, we have negative xb. Why negative? Because I assumed it to left and the positive direction. This is the positive direction for x and this is a positive direction for y. I assumed it to left, so it should be negative. Anything else? Do you have any other forces in x direction? I don't think so. So your xb will be 0. This is the first reaction. This xb equals 0. Second equilibrium equation, we have summation of all forces in y direction equals 0. Please don't forget any. We have positive YA. We have negative 2. We have negative 2. We have negative 2. We have negative 2. And we have positive YB equal 0. Don't forget any forces in y direction. This equation has 2 unknowns, YA and YB. I cannot solve, so I'm gonna simplify it. YA, which is positive, plus YB, which is positive, equal. I'm gonna move these 4 values to the other side. It will be, if they are negative, they will be positive. So we have 2, 4, 6, 8, positive 8. This is the first equation. Do you remember the last equilibrium equation? Do you remember it? You need to pay attention to the third equilibrium equation. Summation moment at any point equals 0. I highly recommend to take moment at one support, probably this support A or this support B. Actually, this equilibrium equation saying summation moment at any point. You can select any point. You can select any point as you like, but I recommend to take a moment at one of the two supports, A or B. It's up to you. It's up to you. For this problem, I'm gonna take moment at B. And I'm gonna assume this direction is my positive direction, which is counterclockwise. So guys, taking a moment at any point equals 0. I recommend to take moment at one of the supports. You can assume any positive direction for moment. What you mean? Moment means rotation. So you can assume this clockwise is the positive direction. It's up to you. Or you can assume this counterclockwise is your positive direction. It's up to you. You can assume what you want related to moment. So I'm taking a moment at B, and I'm assuming counterclockwise is my positive direction. So you are sitting at point B. You are here at point B all the time. And I'm taking a moment at B. Do you remember one more time? Moment means force time distance. Do you remember something here? The force and the distance must be perpendicular. So I'm sitting at B. What do you have? What do you have? We have XB times 0. We have YB times 0. We have 2, this one, times 4. We have this one, 2 times 8. We have this one, 2 times 12. We have this one, 2 times 16. We have this reaction, negative YA times 20 equals 0. Guys, this point is very important. Please pay attention. I decided to take moment at B, so I'm sitting at B all the time. Every force in this problem must be multiplied by distance to get a moment. Please don't forget any force. Let's start. What is the distance between XB and the point B? There is no distance because XB at the same point, so your distance is 0. What is the distance between YB and point B? We don't have distance, 0. You are sitting at B. Remember, all the time you are at B. So let's go. The first force, 2 times this distance, 4. And this force times this distance will rotate counterclockwise, which is positive. Remember, I'm at B. The second force, 2 times this total distance, 8. The third one, 2 times 12. The first one, 2 times 16. And then YA times the total distance, which is 20. And remember, YA times 20 will rotate like this, which is clockwise. You assumed counterclockwise is positive, so clockwise will be negative. This one will be cancelled. This one will be cancelled. The only unknown in this equation is YA. So I can figure out the value of YA will be 4 kip. Can I go back to the first equation and put YA as 4? Yeah, you can. Then I can figure out the value of YB will be 4. So finally, YB is 4, YA is 4, and XA is 0. So I can figure out the reactions in this problem. Anybody has any question so far? Do you have any question so far? Two kept forces and YA forces, sign positive or negative, do not matter, right? As long as you remain consistent. Yes, yes. Go ahead. As I told you before starting, go ahead and assume and be consistent with your assumption during the problem. If anybody assume this direction, another student assume this direction, both of you will get the same answer at the end. Probably with different signs here. These signs will be different between you and the other student, but finally, your final answer will be the same. Let me do one more example. I'm gonna skip these examples. I'm gonna do example number 6. It's a truss. This structure is truss. I don't care. Truss or beam or frame. I don't care. It's not a big deal for me. I'm talking about reaction. So I don't care about the type of structure. A is pin support. So how many reactions do you expect at A? 2. One vertical and one horizontal. What do you think? How can I assume this reaction? It's up to you. It's up to you. You can assume what you want. So I'm going to assume this direction like this and this direction like this. It's up to you. YA and XA, because this support is pin support. Support C is roller support. So I'm going to put one reaction and this reaction perpendicular to this base. The base is horizontal. Your reaction will be vertical. So we have YC. Do you have any other supports? No, we have only 2 supports, one at A, one at C. That's it. That's it. Go ahead and apply your equilibrium equation. This kind of problem are piece of cake. Very easy. The first equilibrium equation summation of all forces in X equals 0. Please be organized. I would like you to solve this type of problem like I'm doing right now. Put your equilibrium equation, summation of all forces in X equals 0, then go ahead and put your numbers or your values. What forces do you have in X direction? Please don't forget any. We have positive XA. We have positive 6 kilonewton. Do you think we have any more? I don't think so. So, equals 0. Can you solve for unknowns? Yes, I can. That means XA will be negative 6 kilonewton. What is the meaning of negative value of your reaction? Negative value of reactions means you assumed the wrong direction. Take it easy. You assume the wrong direction. What did you assume for XA? I assumed it to go to right. Your assumption is wrong. This reaction must be going to left. What should I do? Nothing. Don't change anything. Keep your calculation, keep your reaction, everything's the same. But let me know that your correct direction will be to left. That's it. Don't change anything. XA will be negative 6 to left. Don't change anything on the original problem. Second equilibrium equation summation of all forces in y equals 0. What do you have in y direction? Y direction, I have positive YA. What else? I have negative 8. This one. What else? I have positive YC. This one. What else? Nothing else. Please don't forget any. So, equals 0. This equation has two unknowns. I cannot solve. So, please simplify it. So, YA, which is positive, plus YC, which is positive, I'm going to move this value to the other side. It's negative. To the other side will be positive, 8. And this is the first equation. Do you remember the third one? What was the third equilibrium equation? Summation moment at any point equals 0. Do you remember my recommendation? The general equation, the general equilibrium equation, taking the moment at any point. So you can take moment at A or B or C or D or E. You can take moment at any point. But do you remember my recommendation? Take moment at one of these supports. So I'm going to take moment at A to make my solution or my calculation more easy. And I'm going to assume this direction, which is clockwise, is positive. It's up to you. I like to make positive direction is clockwise. Okay, go ahead. You are sitting where? I'm sitting at A. All the time I'm sitting at A. So go ahead and take force one by one. Don't forget any. I'm sitting at A. So XA times 0. YA times 0. Do you have any distance between XA and the point A? No? Do you have any distance between YA and the point A? No, we don't have distance. We have a force, but we don't have distance. Okay, so times 0. Keep going. Plus 8. This 8 kilonewton is vertical. So your distance must be horizontal to make 90 degrees. So time 2. And be careful. A time 2 will rotate in this direction, which you assumed it as positive. Keep going. We have YC. This YC is vertical. What is the distance between YC and point A? This distance will be horizontal distance. How much? 4. But YC time 4 will rotate counterclockwise. It's negative based on your assumption. Please don't forget any. Do you have any more? Yes, we have 6. This one. This 6 will be positive because this 6 will rotate about point A clockwise direction. I believe it will be clockwise. But anybody can tell me this 6 kilonewton time what? 6 kilonewton, and you are sitting at A. What is the distance between 6 kilonewton and the point A? Any answer? What is the distance between 6 kilonewton and point A? Thank you, John. Okay, guys. Okay, it's tricky. Please pay attention. John, you are right. Here is point A. Here is force 6. Guys, I told you all the time, your force and your distance must be perpendicular. You are sitting at A, and your force is horizontal force. So what should the distance to be? Your distance must be vertical distance. what is the vertical distance between this force and this point? Your vertical distance should be 2 meters. Because your distance and your force must be perpendicular. Must be perpendicular. So the distance between this force and this point, we are not talking about any distance. No, I'm talking about a special distance. Your force is horizontal. So I'm looking for vertical distance between this force and this point, which is 2. Please don't forget nothing else. All of this stuff equals 0. And remember, this force times this distance would like to rotate like this, which is positive. XA times 0, 0. YA times 0, 0. The only unknown in this equation is YC, so I can figure out the value of YC. What is the value of YC? Let me do it. 16 plus 12 divide 4 will be 7 kilonewton. Positive. Positive means you assumed the correct direction. So YC equals 7. So go back and put YC here, 7. So I can figure out the value of YA. It will be positive 1. So YA equal 1. XA equal 6 on the other direction. And YC equals 7. I am done. I am done. Let me do one more example. We have a truss. I don't care. I don't care what you have. A is pin support. That means we have one vertical reaction YA, one horizontal reaction XA. I can assume any direction, left or right, up or down. Point D is a roller support. So we have one reaction perpendicular to this base. So we have YD. How many equilibrium equations do you have? We have 3. Summation f of x equals 0. Which forces in x direction? Please don't forget, be careful. We don't have any except positive XA, nothing else. Yes, so equals 0. That means XA equals 0. Summation of all forces in y direction equals 0. So what do you have in y? We have positive YA. We have positive YD. We have negative 2. We have negative 4. We have negative 2. Don't forget anything in y direction equals 0. Go ahead and simplify this equation because I cannot solve. So YA, which is positive, plus YD, which is positive, equal 8. Equation number 1. The third equilibrium equation will be summation moment at any point equals 0. Which point? Any point. I told you any point. So you can take moment at A, at G, at B, at F, at C, at D, or E. But I highly recommend to take moment at any of the 2 supports, A or D. I recommend A. And I'm going to assume clockwise is positive. It's up to you. Clockwise is positive or counterclockwise is positive. It's up to you. If you take moment at A, I'm sitting at A. All distance must be measured to A. Do you have distance between XA and point A? No. Do you have distance between YA and point A? No. Do you have any distance? What is the distance between this force 2 and point A? Any answer? What is the distance between this force 2 and point A? What is the distance? This force 2 and point A. What is the distance? Oh, thank you, Mitchell. John, you are wrong. Mason, you are wrong. Guys, here is the force 2. Here is point A. Your force and your distance must be perpendicular. This is the last time I will remind you for this rule. So, in this case, we have a force which is vertical force. And we are looking for horizontal distance. Your force in this time is vertical force. So your distance must be horizontal. Do you have any horizontal distance between this force and this point? Do you have any horizontal distance? No. That means times 0. Guys, 2 kilonewton, if you extend it, it will be through point A. So we don't have distance like XA, like YA. So I don't care positive or negative. The next one, 4. Yeah, okay. What 4 is vertical force. That's right. And I'm sitting at A, so I'm looking for horizontal distance. Do you have horizontal distance between 4 and your point? Yes, we have. How long? 3. And rotate clockwise. So it's positive. What else? This 2. This 2 is vertical force. So I'm looking for horizontal distance. Do you have horizontal distance between this force and point A? Yes, we have 6. Positive. Then YD. YD is a vertical force. So I'm looking for horizontal distance between this force and point A. Do you have distance? Yes, we have. We have 6. And this force will be negative. Why? YD times 6, rotate like this, which is counterclockwise, opposite your assumption, so it will be negative. Anything else? Please don't forget any. So XA, YA, 2, 4, 2, and YD, nothing else, equals 0. From this equation, I can cancel XA times 0, YA times 0. The only unknown in this equation is YD. So I can figure out the value, and the 2 times 0 also will be cancelled. So YD will be positive 4 kilonewton. If you put here YD equal positive 4, I can figure out the value of YA will be positive 4 also. So XA equals 0, YA equal 4, YD equal 4, and I am done. I am done. Guys, remember, please, don't forget this rule. Don't forget, you are sitting at a point and you have a force anywhere. Please remember, if you are looking for a distance for this force to make moment, please don't forget your force and your distance must be perpendicular. So if your force is a horizontal force, your distance must be vertical distance. If you are looking for a distance for this force, for example, this force is a horizontal force, is a vertical force. So your distance must be horizontal. Your distance and your force must be perpendicular. It's a tricky. Be careful about this point. let me go back to example number 3. Until this moment, do you have any question? So, any question so far? Okay. Guys, sometimes we have a kind of distributed load. We have a kind of load called distributed load. Actually, we have different type of distributed load, but in this course, I'm going to focus only on uniform distributed load. Uniform means we have a piece of the structure covered with uniform distributed load. Uniform means constant value, like this. And this value probably W, kilonewton per meter, or pound per foot. I mean, it's a force unit per length. Actually, we need to do some adjustment, because are you working with this arrow or this arrow or this arrow? We need one person to talk to. Can you remember the concentrated force? If you have a concentrated force, so we have only one value, and this value time a distance, we can get a moment. So we need to deal with one value. So I'm gonna make equivalent for this distributed load at this location, at the middle. So this distance will be L divide 2, and this distance will be L divide 2. At the middle, the location of the equivalent value will be at the middle. How much this value will be? This value will be this uniform load value W time this total distance L. So let me do an example here. If I have piece of beam with distance 10 feet, and this uniform distributed load equal 5 kb per foot, what is the value of the equivalent force and where? Where? At the middle. So this distance will be 5 foot, and this distance will be 5 foot. How much? This equivalent load will be this value of the distributed load, which is 5 kb per foot, times this total length, which is 10. So your value will be 50 kb. So finally, this load can be removed, and we can put here a value equal 50 kb at distance 5 from this side and 5 from the other side. What I did is equivalent replacement for this distributed load to only one value. Any question for this point? So if you have uniform distributed load, please make equivalent value, make equivalent calculation for this distributed load to be one value. And please be careful about where is the location of this equivalent. So we have example number 3. We have a beam and we are looking to calculate reaction. How many supports do you have? Actually, we have only one support at A, which is fixed. Guys, do you remember if you have fixed support, how many reactions do you have? if you have fixed, do you remember how many reaction? 3? Yeah, I think 3. 1 vertical, 1 horizontal, and one moment. So if you have fixed support, we have 3 reaction, 1 vertical as a force, 1 horizontal as a force, and 1 moment. We have the same case here. So we have reaction YA, we have reaction XA, and we have moment MA. It's fixed. Please don't forget, for fixed support, we have 3 reactions. Before starting to apply your equilibrium equation, we have something we need to adjust. We have distributed load. This distributed load we need to make equivalent. Here. How much is this distance? 1 meter. How much is this distance? 1 meter. How much is this value? You know? What is the value of the distributed load? It's 10. What is the total length of this distributed load? Is 2 meters. So this value will be 20 kilonewton. So if you would like to redraw this beam, if you would like, this beam will be looks like this. We have fixed it here. So we have 3 reaction, 1 vertical, 1 horizontal, and 1 moment, like this. YA, XA, MA. And we have equivalent force here. How much? 20 kilonewton. And we have already given concentrated load here, 10 kilonewton. Guys, I used 2. If you have uniform distributed load, I used 2. Assume this equivalent, something looks like this, zigzag shape. If you look to this shape, so you can understand this force, it's not a given concentrated, it's equivalent for something else, for a distributed load. So all the time I'm gonna make this equivalent looks like zigzag, like this. It's just for fun. Anyway, so, okay, go ahead and apply your equilibrium equation. How many? 3. Summation of all forces in x equals 0. What forces do you have in x direction? We have negative XA. Do you have anything else? No? Equals 0. So XA equals 0. Piece of cake. Summation f of y equals 0. What do you have in y direction? We have negative 10. We have negative 20. We have positive YA. Do you have anything else in y direction? No, we don't have. Equals 0. I think this equation I can figure out this unknown. So I can figure out the value of YA will be 30, positive 30 kilonewton. Keep going. Keep going. And I have a question. And if you answer this question, I will give you extra 3 points. So please pay attention. What is the third equilibrium equation? What is the third equilibrium equation? Moment. Okay, but this is not the question. So summation moment at any point equals 0. Do you remember my suggestion, my recommendation? Take moment about what? Any point. But my suggestion, recommendation, take moment at one of the supports. How many supports do you have here? Actually, we have only one at A. So I'm going to take moment at A. And I'm going to assume counterclockwise is positive. It's up to me. It's up to you or up to me. So I can assume any direction. So I will assume counterclockwise is positive. So I'm sitting at A. I'm sitting at A. XA time what? YA time how much? MA time how much? Guys, we have YA, we have XA, we have MA, we have 20, we have 10. You are sitting at A. Let's start with YA. What is the distance for YA? What is the distance for XA? What is the distance for MA? Any answer? Okay. So XA will be multiplied by 0. That's right. YA will be multiplied by 0. That's right. My specific question, MA time what? What is the distance for MA? What is the distance for MA? You are at A. You are sitting at A. And your moment also at A. So what is the distance between A and MA? Both of them at the same location. So what is the distance? I'm sorry, guys, all of you are wrong. This is a very tricky point. MA does not need a distance. Force, if you have a force, you need a distance to make moment. If you have force, so you need distance to get a moment. But if you have a moment, you already have a moment as a reaction. This reaction MA is a moment. It's moment. Do you think we need distance? No, because it's moment. So we don't need distance. So MA does not need distance to be a moment. XA is a force, still need distance. YA is a force, still need distance. MA is a moment, it's reaction. I know, but it's moment, does not need distance. So MA will not multiplied by any. Keep going. We have positive 20 times 1. We have positive 10 times 3 equals 0. This term will be cancelled. This term will be cancelled. The only unknown in this equation is MA. So I can figure out the value of MA. The second trick in this topic about moment. I know this is the first time to talk about fixed. So keep in your mind, it's very important. It's a tricky point. Keep in your mind, if you have fixed support, we have vertical reaction as a force. We have horizontal reaction as a force. We have moment as a reaction. If you are taking a moment at any point, if you are taking a moment at any point equals 0, please remember, if you have a force, this force still need distance to make moment. If you have a force, this force still need distance to make a moment. But if you have a moment, this value or this moment does not need distance. So please don't multiply this one by any. Did you get it? Did you get it? Great. Okay. Okay. Just, I'm sorry, guys, but give me 4 minutes more to finish up this example. By the way, the due date of homework number 5 is extended until Wednesday. It's not Monday. We still have quiz on Monday, but the due date for the homework until Wednesday. Okay, because I didn't finish up. For this problem, we have a frame. I'm sorry, frame? Yeah, I don't care. Frame or beam or truss, I don't care. We have roller support based on the information, roller support at A. So we have vertical reaction here, YA. We have pin support at C. So C is pin. So we have two reactions, one vertical and one horizontal, XC, YC. We have uniform distributed load. So I need to make equivalent. This equivalent will be here at the mid distance. So this distance will be 5. And this distance will be 5. Anybody can tell me what is the value of this equivalent force? How much? It will be 1.5, the value of the distributed load, times the total distance, which is 10. Your final answer will be 15 kip. Go ahead and apply your equilibrium equation. Summation f of x equals 0. So we have negative xc, we have negative 2 equals 0. So xc will be negative 2. You assume the wrong direction. What did you assume? To left? No, it will be to right. That's it. Summation f of y equals 0. What do you have in y? We have ya positive. We have negative 15. This equivalent. What else? We have positive yc. Nothing else. So simplify, this one will be ya plus yc equal 15. The last one will be taking a moment at any point equal 0. So I'm going to take moment at C. Do you remember my recommendation? Taking a moment at one of the two supports. To be more specific, I'm going to take moment at the support with more reactions. So I'm going to take moment at C. If you take moment at C, I'm going to assume this counterclockwise is positive. Okay, go ahead. I'm sitting at C. YC time what? 0. XC time what? 0. 2 time what? This 2 time what? This 2 is horizontal. And you are sitting at C. What is the vertical distance in between? Is 6. 15. 15 is a vertical force. So what is the horizontal distance between this force and point C? It's 5. YA will be negative. YA is vertical. What is the horizontal distance between YA and the C? It will be 10. Equal 0. Nothing else. Guys, please remember, if you have a force, this force will need distance to make a moment. But if you have a moment, we don't need distance. So this one will be cancelled. This one will be cancelled. The only unknown here will be YA. So I can figure it out. Go back to this equation, put YA, and then you can figure the value of YC.